Assalamu alaikum students. I am your teacher Aisha Anwar. Welcome to the computer class. I hope all of you are fine and doing good with your studies. We have started chapter number 5 from your book, which is about arrays. In previous lecture, we have covered the basic concept of arrays, that what are the arrays and what is its purpose. And we have covered one-dimensional arrays in our previous lecture. In today's lecture, we are going to revise some important concepts from previous lecture, and today we will learn about two-dimensional arrays. We have discussed that arrays basically allow the programmers to use a single variable name to represent the collection of same type of data. We have discussed that when we want to declare an array, we have to use the same type of data. For example, if I am going to create an array of integer data type, so it means all the elements of array should be of integer data type. We learned that we can declare an array by mentioning the data type, then name of array, then within square brackets we use or we mention the size of array, and then we close the square bracket and put the semicolon. This is the way to declare an array. I have declared the array of size 2 over here with the name A and its data type is int. So it means that I am going to create an array of integer data type. So basically, what is the purpose of using arrays? The purpose of using arrays is to reduce the program size and provide easy way of handling a long list of variables or the numbers or the strings, and makes computer programming much simpler and easier. This is the basic purpose of array. We also discussed that there are two types of arrays used in C++. These are one-dimensional arrays and two-dimensional arrays. Basically, one-dimensional array is a collection of rows or a column. Basically, it is a single row or a column. Like if we represent an array like this in the form of some diagram, so this is the 1D array or one-dimensional array, which contains only one column or one row. One-dimensional array cannot contain more than one rows or one columns. These are two separate one-dimensional arrays. Arrays basically stores the list of variables at consecutive memory locations. But now, what is 2D array? 2D array is basically a collection of rows and columns. 2D array is in form of multiple rows and columns, that is in the form of a table. This is how two-dimensional array or 2D array appears. It has 12 memory locations. It has more than one columns. This is column 1, this is column 2, this is column 3, and this is column 4, and these are the rows, row 1, row 2 and row 3. So 2D array is in the form of table, and we have discussed that 1D array is just a single row or a single column like this. This is the diagrammatic representation of 1D array. Here we have discussed that there are a few things that are associated with an array. First of all, we must know the length of an array, that the length of this array is 10. The array index is always started with the 0. As the length of this array is 10, so starting from 0, the last index of this array is 9, and the values that are stored in the arrays are known as the elements of the array. For example, this is the fifth element of the array. So this is the diagrammatic representation of 1D array, which contains only single row. Now let's come towards the formal definition of 2D arrays, that how can we define our 2D array. In C++, two-dimensional array consists of more than one rows and more than one columns. So it means it creates in the form of a table. In 2D array, each element is referred by the two indices. That is different from the 1D array. We refer the element in 1D array by the 1 index. Then the first index shows the rows of the matrix and the second index shows the column of the matrix. For example, over here, this first 7 is showing the number of rows, that this matrix will contain 7 rows, and this 7 means there will be 7 columns in this array. Again, two things are the same, like we have to mention the data type first, then the name of the array, then within square brackets, first of all we mention the rows that we need, and then in second square brackets we mention the columns that we require to create the 2D array. This is the diagrammatic representation of 2D arrays so that you can understand it in much better way. First of all, look at the first diagram. These are the rows, row 0, row 1, row 2, row 3, and so on, like row 4. These are the columns 0, this is the column 1, this is the column 2, column 3, and the columns do you want, like how many columns do you want, then you can select any number. Now, what is this location called? First of all, we mentioned the rows, that this is 0, 1. So this location is the 0, 1 location. Now what is this location? First of all, you have to mention the row number, that is 1, and then the column number, that is 3. So this location is the 1 and 3. Now come towards the second diagram, that how we numbered the indices in the 2D arrays. Like in 1D array, it is very much simple to Number the indices because they are simply 0, 1, 2, 3, and so on. But in 2D array, you have to learn about the indices. This is the first location, and we know that the first index of the array is always 0. So this is 0, 0, which means 0 row and 0 column. Then this is again 0 row and 1 column, 0 row and second column, 0 row and the third column. So this is 0, 0, 0, 1, 0, 2, and 0, 3. Now this is the second row. So starting from the 0, now it will becomes 1, 1, 0, 1, 1, 1, 2, and 1, 3. Now in the end, this is row 3. So starting from the 0, then 0, this is 1. So it will be 2, 2, 0, 2, 1, 2, 2, and 2, 3. In this manner, we number the indices of an array. This is how we can initialize and declare a 2D array. First of all, let's discuss the first example. Here we have initialized an array with the declaration of the array. We have declared the array with the name MAT, and the data type is int, so it means it is an array, 2D array, which can store only integer type of data. Int mat 3 rows and 3 columns. Within square bracket means the first index is for rows and the second index is for the columns. So these values will be assigned. Now open up the curly bracket, then put the next curly bracket to separate the rows and columns, 3, 6, 8, then close the curly bracket, put comma, then the second row, 5, 4, 7, close the curly brackets, put comma. For the third row, open another curly bracket and 2, 4, 7, close the curly bracket and close this main curly bracket for this curly bracket and put the semicolon in the end. When this code will be executed, a matrix will be created of size 3 rows and 3 columns in the memory like this. First of all 3 rows and then 3 columns. Now how these values will be assigned? First of all 3 will be assigned over here, 6, 8, 5, 4, 7 and 2, 4, 7. When this code will be executed, a matrix, an array will be created of name mat, and it appears like the matrix, those matrices that you study in your mathematics. And this is how the values will be assigned to the rows and to the columns. Now come towards the second example that is mentioned. First of all, we have declared the array of data type int again, and the name of the array is matrix, and the size of the array is 5 into 5, which means 5 rows and 5 columns. Now here you need to notice that we have used the nested loop over here, as we have discussed that for using 1D array, we must have used the loops to access the elements of the arrays. But for 1D array, we only use a single loop for that. And in 2D arrays, we use nested loop. One loop, the first loop or the outer loop is used to control the rows, and the inner loop is used to control the columns. First of all, look at the outer loop. For m1 is equals to 0. Why is it starting from the 0? Because we know that the first index of the array is always 0. So please be careful while using the loops for the arrays. They must start with the index 0. How many times will this loop will be executed? When m1 is less than 5, and here is the increment m1 plus plus. Now for this loop, there is another loop. m2 is equals to 0. Then m2 is less than 5, and this is the increment m2 plus plus. Now we are storing the value m1, m2 is equals to 5. When this code will be executed, array will be created with the name matrix, and all the values of that array will be 5. When this loop will be executed for the first time, m1 is 0 and m2 is 0. So matrix 0 and 0, 5 will be assigned to matrix 0, 0 location, then 0, 1 location, then 0, 2 location, 0, 3 and 4. Then for the next iteration, m1 will be incremented, then 1, 0, 1, 1, 1, 2, and in the same way the matrix will be filled, and all the elements that are assigned to that matrix are the number 5. Here is the example for 2D array initialization and declaration. As we have already discussed that we use nested loops to perform any operation on 2D arrays. Let's go through this program and understand what this program is calculating. First of all, here we have a array named matrix, and its data type is integer, and the size of the array is 2, 3, which means this matrix will be having 2 rows and 3 columns. Now we have used the nested loop to fill the array named matrix. When this loop will be executed, first of all, the value for both variable will be 0 and 0. So whatever user will enter the integer, it will store to the value at the location 0 and 0, then 0 and 1, then 0 and 2. Again in next iteration, the value of m1 will be 1, then 1, 0, 1, 1. In this way, the array will be filled. User will enter the values, and these values are controlled with the loops, and according to that, the values will be stored in the 2D array. Now, here we have used another nested loop to display the elements of a matrix on the screen that user has entered. For example, m1 is equals to 0, m1 is less than 2, and m1 plus plus. Again, this loop is same as the previous one. Here there is only one difference. In this part, line number 12 and 13, we have input the values, and here in line number 23 and 24, we are outputting the values of the matrix. This is the very simple example that I have discussed with you. This is how we can fill and print an array, a 2D array basically. Now you have to keep it in mind, whenever we are using 1D array, we use only one loop because 1D array only contains one row or one column. But whenever we use 2D arrays, we always use nested loop. One loop is to control the rows and the other loop is to control the columns. Write down this program in Dev C++ and practice it for the concept. It is a very simple program. Now, there is a function mentioned in your book, size of function. What is the size of function basically? Size of function provides the number of bytes occupied to store the values for data type named within the parenthesis. You will understand it with the help of example. I am going to quote an example in the next slide. Basically, it is used to determine the amount of storage reserved for the data types like integer, floating, double, and character. When we studied in chapter number 3 about these data types, I have showed you a table, and this table is also given in your books, that how much space is occupied by these different data types. Integer data type stores some different values than the floating data type. Floating data type takes some different storage capacity than double and character data types in the memory. The basic purpose of size of function is to find out the storage capacity or the storage reserved for these data types. This is the example. You can understand it with the help of this example in much better way. Here, it is a very simple program just to show the demonstration of the size of function. Cout, size of character, and here we have used the size of function. We have used the reserved word size of, and within bracket we have mentioned the data type for character. That character data type will take how much memory. Then size of int, again we have used the reserved word size of, and within the bracket we have passed the data type integer. Then cout, size of short int, then cout, size of long int, then cout, size of float, then size of double, and size of w character underscore t. And if you have noticed that we have used the size of function, this is the syntax of the size of the function, that first of all we have to use the reserved word size of, and within these simple brackets we have to pass the data type for which we want to check the size. When this code is executed, this output will be displayed. That size of character is 1 byte in the memory, size of integer is 4 bytes into the memory, size of short int is 2 bytes in the memory, size of long integer takes 4 bytes of the memory, size of float is 4 bytes of the memory, size of double is 8 bytes of the memory, and size of w character underscore t is the 4 bytes in the memory. So these are the different sizes of the data types that are reserved into the memory when this type of variable is created. Here is your today's task. You have to write a program in C++ to find the average of a matrix. It means that first of all you have to declare a 2D array. You can give any name to that 2D array, or simply you can give that name matrix. Declare 2D array. Then you have two options. Either you can assign the values to the arrays by yourself, because I have not mentioned anything, or you can get the input from the user by using the nested loops. After assigning values to the 2D array, you have to find the average. For average, first of all, you have to find out the sum of the values of the 2D array. You can take the help from the previous lecture in which we have found out the total and average of 1D array. In the same way, you have to perform the same calculation but for the 2D array. Those who are having the facility of Dev C++, they can do it on their computers. Otherwise, you can simply do this task on your registers and share with me. That's all for today. I hope you have enjoyed today's lecture and you have learned the new and interesting concept of 2D arrays. Still, if you are having any problems, you can ask me. Please submit your task in given time, that is within 24 hours of this lecture, so that I can mark your attendance. That's all for today. Have a good day. Thank you.